So we're on question 4. Prove algebraically that n cubed plus 3n minus 1 is odd for all positive integers n. Notice this isn't a quadratic, we've got a cubic equation. Right, when we're talking about something being odd or even, then we need to consider the cases where the number that we put in is odd or even. And that's the first thing that we need to think about. So we need to deal with that first. So if n is even, then we can write it as being 2 times something. So if it's even, it can be written as n equals 2k. I'm using k. I can use whatever letter that I like. So that means the equation n cubed plus 3n minus 1 is 2k cubed plus 3 times 2k minus 1. The minus 1 didn't work, there we go. And I've got to do something with that, so that's 8k cubed plus 6k minus 1. Well, that is an even thing plus an even thing, because 2 is a factor of both of those. Take away an odd number. That, in other words, what we could do with that, this would be a nice way of doing it, is say that's 2 lots of 4k cubed plus 3k minus 1. And that's of the form two times something minus 1. And 2p minus 1 is always odd, because it's an even number, take away 1. Okay, that seems like a reasonable way of saying that, doesn't it? If n is odd, then we're going to let n be equal to 2k plus 1, because that's the form of an odd number. We could equally write 2k minus 1. So n cubed plus 3n minus 1 is going to be 2k plus 1 cubed plus 3 times 2k plus 1 minus 1. And we're going to have to deal with this. Well, 2k plus 1 all cubed, you could, if you want to, you could go for a whole kind of multiplying out the brackets carefully one at a time. It's a binomial expansion thing as well, so you could think of it that way. It's however you want to do that. It's 2k cubed plus 3 times 2k squared plus 3 times 2k plus 1 plus 6k plus 3 minus 1. So we're going to write it like that. That is 8k cubed plus 3 times 4k squared, so 12k squared, plus 6k plus another 6k, plus 1 plus 3 is plus 4, take away 1. And it's convenient to write it like that, isn't it? Because then we've got 2 lots of 4k cubed plus 6k squared plus 6k plus 2 minus 1, which again, of the form 2p minus 1, and the form 2p minus 1 is always odd. For any integer p. So again, we're saying that it is odd again. Are we happy with that? It's about analysing those 2 different cases of when n is odd and n is even, and confirming that both of those gives you an odd result at the end of it. There we go. And that's maths.